got a whole bunch of these microphones. I think they're all electric condenser microphones, and I wanted to test them. So I bought this bag here for a repair, for something, for a walkie-talkie, I think. So a whole collection for not much money. But I'd like to test all these and make sure that they actually work, that these are all good mics. So what I thought I would do is build an electric preamp. So I had a look around on the internet and found, well, this circuit appears a number of times on various different sites, and you can see it's basically just got the one transistor amplification stage, often the 2N3904, which I think I've got in my box of things. And you can tell this is an electric amplifier because electric microphones need to have a bias current going in, so they need to have some current flowing through a resistor into the electronics in there, because actually electric microphones have got a little MOSFET inside which needs some voltage across it. So you just got the electric microphone here, and this capacitor stops any current from here flowing into the base of the transistor, because the base already has a bias current through this 100k resistor. So this is a pretty simple setup, and so I'm going to solder a few components together, probably on a bit of strip board, and then we'll get to testing the mics. Right, so I finished assembling the components onto the board, and I managed to find all the correct values, so I didn't have to substitute anything. So this is a 2N3904 and a new one as well, so that's good. So what I'm going to do is I'm going to attach the mic on those wires here. So this is the input side here, and then over here we've got the power rail plus and minus at the top and bottom, and then the capacitor leads to the output here, so I can clip on a lead and connect it to the oscilloscope there. Yeah, so I'm going to power it off this battery box. So this is 3 volts, so I'm going to give it its own self-contained power supply, at least to begin with, because there's less chance of external interference, so noise in the signal if we just use a battery box. Right, so we're all connected up now, and I've got one of the electric microphones plugged into the wire here. It's not shielded, so it might be a little bit noisy. We've got the oscilloscope probes plugged in here, and so if I say hello into the microphone here, or 1, you can see that's now picking up, so there's quite a good signal going in there. And what I could try doing is playing this panpipe. So we see quite a good signal there. Now I might stop the scope while that's playing, and we can have a look at the waveform. So right, so we can see we're set here to 200 millivolts per division. It's quite hard to see the divisions in this light, but it's 1, 2, 3, at least 5 divisions. That's, these peaks are like 1 volt peak to peak, which is not bad. That's reading 200 kilohertz, which is a bit low, because I know this is it's a panpipe tuned to A, which is 440 hertz, and obviously that's a bit of a raspy tone. It's not really a pure sine wave, so it looks a bit jagged with harmonics and so on, but you can see that the preamp is actually working. So what we could do now is switch round and connect it to a recorder and record some speech, and then we can see what the quality of the audio sounds like. So I'll do a bit of rewiring and then we'll have a go at that. Okay, so I've got everything connected up. I think this is a cable going into the sound card, into the microphone socket on the sound card. So I've just got the tip and the end of the sleeve connected there into the output of the preamp. So I think that's right for an already amplified microphone. The microphone I've got sort of pointing up vaguely towards my face here, using this elegant reel of solder solution. And so I'm going to try and record some audio into Goldwave, is the program that I'm using. So if we have a look at the screen here, if I hit record now, you can see this bar jumping up and down. So this is actually measuring the input volume in real time. There was a little tooltip there. See if I can get that to jump up again. No, it doesn't want to play now. Perhaps if I stop. Oh, that looks pretty good. I'll start again. Okay, so the volume's only set at 33%, but that looks like plenty, doesn't it? Because the volume is going up into this orange zone here, so it's good and loud. And if I just stop and play that back, I'll start again. Okay, so the volume's only set at 33%, but that looks like plenty, doesn't it? Because the volume is going up into this orange zone here, so it's good and loud. So I can hear a bit of hum on that, but it's not too bad. And of course, none of this is protected, none of this is shielded, and the mic cable is just just a couple of bits of wire instead of being coax or something to to protect it from noise pickup. So if I record a bit of speech now, and then I can inject this into the video, and you can judge for yourselves what the quality is like. So here goes. Bright star, would I were steadfast as thou art, not in lone splendour hung aloft the night, and watching with eternal lids apart, like nature's patient, sleepless eremite. There we are. Okay. Bright star, would I were steadfast. Right, so I'll put that into the video just here, and you can listen to that for whatever that is, 15 seconds. So we'll put it here. Bright star, would I were steadfast as thou art, not in lone splendour hung aloft the night, and watching with eternal lids apart, like nature's patient, sleepless eremite. Right, so I hope you enjoyed that short Keats recital, but it looks like I've got a working solution here. So now I can actually go through and I can plug all the mics one after another into this socket and do a test recording, and then I'll be able to tell which of the microphones is good and which ones I can just chuck out. So that's a good afternoon's work, I think. Alright, thanks very much for watching, and I'll see you in the next video. Okay, just a final word. So these microphones turned out to be good, so I tested all those ones and get a good level of signal, and I've also got a good load of defective ones. So a couple of those ones that I had in that bag from China have very, very low levels of signal, not really usable. At least one of these is completely bust. So yeah, that was a worthwhile activity.